Okay, so I actually just recorded the next episode, but then halfway through I realised I could probably do this whole thing a lot better, because I've figured out I don't actually have to use the houghcircles function down here. I'm pretty sure I can get away without this entire function, and I can just sort of scan the centre of every square and check which ones have colours and which ones don't. So I'm going to quickly go through the important parts of what I've just been through, but a lot of it was irrelevant, so that's why I'm not uploading that video. So what I did, I created a new variable called border pixels. This is going to be the board as a numpy array containing all the pixel locations of every square. So you can see the output here. It's got basically every square, the x, the y, and you got like a 5x5, so you've got the entire grid. So that's what that is. That's what that function does. It takes in the dimensions of the board, the size of the board, the size of the square, and it takes in center of circles, but it doesn't actually need to take in center of circles. So this can be one of the edits I make. I'm going to get rid of that. Now, it doesn't need to take it in, so I'm not going to pass it into the function here. Now, x dimension, y dimension, this is the starting position of the image with respect to the screen, because obviously when we take our screenshot it's not capturing the whole screen, so we need to pass in like where it's capturing from. These are basically taken from dimensions of board, so we've got 30 and 165, because basically there's a 30 pixel border on the left, there's a 165 pixel border on the top of where all the board is to the edge of the screen. So that's what we're passing the user for. Now, this whole thing here, this is irrelevant now, so I'm just going to comment this out for now. We're going to move this just in case we have to come back to it another time. I'm going to move it somewhere in a sec, but for now we'll just leave it there. So now border pixels is equal to numpy.zeros, size of board. So what this does is it creates a zero array with size of board rows and size of board columns, and now I've made the data type equal to object, so it's going to take in objects rather than just ints or strings or whatever. So the reason it takes in objects is because, as you can see, we take it in like 2 values for every square, so it's taking in a tuple basically, so we need it to accept tuples as an input. So to fill this board in, because obviously this is still zeros at this point because it's numpy.zeros, we do a for loop over I in the range of size board, so I in range 5, for j in range 5, and then we loop through basically every square and set the x position, which is this part right here, equal to the x dimension. So where's it starting at? You'll follow the mouse on the game right now, so it's starting like sort of on this line. It's going to plus j times the size of square, so for the center of this red one it's going to plus 0 times the size of the square, so it's going to stay here, and then it's going to add on half the size of a square, so half the size of a square will take you to roughly the center. And then for the y axis is basically the same but come from the top, so you add on this extra half square to get you into the center of the squares, and obviously we're using 0 indexing, so the first one is obviously 0, so this thing here returns 0 for the first one. It's pretty simple. Hopefully this makes sense here. So after looping through here, this is basically where all the pixel values are input, and now we can return it. So we're going to return this, and then we're going to use this to scan our board for colors using another function. So we're going to get rid of this print statement here, and I'm going to move this comment. So we're going to move this to locate colors just because it relates to that kind of, but we're not going to actually be calling this function anymore. I'm going to get rid of this. We probably don't need it, so I'm going to comment that out. Now next thing to do is we want to have some sort of function that's going to loop through all these pixel values and create basically a board of colors. So board of colors is equal to this isn't going to be going to call this create pixel board, create pixel board, create color board. Okay, so color board is going to take in, the border pixels. It's going to take in the. Does it need to take anything else in? I don't actually think it does. That might be the only thing it needs. So if we define create color board, pass that in border pixels, and now we need a list of all the possible colours we can find on the board. So if we look at, I've previously done this, but you can see where I got it from. So basically, if you look at the 14 by 14, there's loads of different colours. We need to basically create a dictionary with all the colour values in it, the RGB values. So if you look here, hopefully you can see this. I think you can. So you can see the RGB values of every colour. They're very consistent. They're like a block of colour, basically. Actually, this one's changing a little, but hopefully this isn't going to be too much of an issue. This might be an issue. Do any of the others change? Why does this one change? Grey changes slightly as well. Okay, so we might have to implement some sort of range to detect the colours. We can come back to this. Basically, the way we're going to do it now, it should work quite simply for the 5x5s, because you can see these ones are very solid. There's no variance in their colour anywhere. So yeah, for now we're going to stick to my original plan. We might have to add some sort of range in this eventually, but for now we'll stick to this. So what we're going to pass in is, I'm just going to copy this over because I've already done this before. We're going to pass in a list of all the possible colours with all the possible letters. And if I can find it. Okay, so addictive colours is equal to, so we've got blue, red, green, yellow, orange, purple. Can't remember what that is, but basically some of them like had to be doubled up and whatnot. So basically all you need to know is an independent letter for each colour. Each of the colours are programmed in here, coded in here. And we need to add one more to this, and that's going to be actually no, we don't need one more. So that's going to do for now. And then we're going to say, whoops. So one more thing we're going to have to actually pass into here is the size of the board. Might not have to pass this, but we can. Might make life a little bit easier. So for passing size of board, we can then do, actually is this done? Yeah, this is done with spaces. Let's just get rid of that. Okay, so numpy, sorry, board of colours is equal to numpy dot array. No, numpy dot, we'll do zeros again. Numpy dot zeros, size of board, This time we want the data type to be equal to strings, so we're not going to be passing objects this time, it's all going to be single value, single like things, so we're going to pass zeros and letters, these are the letters we're going to pass. So now we want to be checking every pixel in border pixels for is it in the dictive colors. If it's in the dictive colors, we're going to let that position equal the color letter. If it's not, we're going to let it equal a 0 for there being nothing there. Now if you can see on the game, there's like things passing over the background, so we're not always going to get a black background, which is why we're going to say if it's not equal to the colors instead of if it equals black, because these colors could throw it off a little bit. So I'm going to get on with that quick and we'll be back once I've done it. Okay, so what I've done is I've looped over I for the range size of board, and I've looped over J for the range size of board. I've then printed the py_pixel, which what you do with py_pixel is py_pixel, you pass in a x and a y value, and then what it'll do is it'll go to this x position and y position, and it'll return a tuple of the RGB value at that position. So what we're going to do is, instead of passing it x and y, we're going to pass it board of pixels ij, so whatever these ij values are going to be, we're going to go here, then the 0th element, and then the y we're going to do ij again, then the first element. So if you remember what board of pixels returns, you can see right here. So we're going to, for ij, so obviously it'll start at 0, we're going to return this first group. This is the x, this is the y, then second one, this is the x, this is the y, and obviously it'll loop through this, it'll do every pixel, or every square, sorry, every pixel of every square I guess, and then it'll return what their RGB value is, and it'll print that. So I'm just going to run that right now and show you what it looks like. So you can see here, if this is on screen, which I think it is, yeah it is. So you can see, if I drag this down, hopefully this stays on screen. Actually you only need to see the top, just look at the top. So you can see for the first square it's got, I'll bring up this as well, so you can see the RGB values. You can see for the first one it's got red, you can see that is red. Second one it got this like white colour in the background, 10 10 10. Like I said, these things in the background could mess it up, but we're going to hopefully manage around that. Then it's got green, 0 1 2 8 0. Then it didn't actually pick up this line because this line wasn't there at the time. Obviously this game's constantly moving. It was actually black, so it'll have picked up this colour right here. Then it picked up yellow, and then it went down here and picked up black. Then it picked up this white again, so 10 10 10. Then blue, 0 0 2 5 5. So you can see it's basically gone through in list in like order, done all these, read the center pixel and returned their RGB value. So now what we're going to do is we're going to, instead of printing this, we're going to say if this RGB value is in the dictive colors, and then we're going to want the keys, so dictive colors dot keys, because these tuples are the keys and the letters are the values. Hopefully you understand how dictionaries work, but basically for every dictionary, for every element in a dictionary, you pass it a key and a value, and the key corresponds to the value corresponds to the key. So in our case the keys are the tuples, so we're going to want to check if the tuple, the colour, is in the keys, which is our tuples, and if it is, we're going to want to return, we're going to want to change the board of colours ij, so if it is board of colours ij is equal to, and then we're going to want it to equal, if it is in there, we're going to want it to equal the colour. So say if we do find blue, we're going to want it to equal B, so we're going to want it to equal dictive colors and then we're going to probably need to pass this bit again, I think. So pi auto GUI dot pixel. We're probably going to need to pass this whole thing again, I think. Now if we come out of this, else, because if it's not, then we want to say that the board of colours I J. Actually, we don't actually need this because it's starting as a. Maybe we do, because we want it to be a string. We don't want it to be an int. Equals. We could say 0. Now, if we print this board, we'll see if this worked. I'll be quite surprised if this works first time, but let's have a look. Okay, so it looks like it has. You can see we've got an array, all strings. We've got red, then 0. So we'll look at this, these top two rows. So we've got red 0, green 0, yellow. So red 0, green 0, yellow. Then we've got 0 0, blue 0, orange. 0 0, blue 0, orange. So you can see this has probably worked. It looks like it has to me. If I check every colour, yeah, it has. Yeah, so I'm quite happy with that. So that's probably about it. We're going to want to return this, and now next episode we'll be working on how to solve this, how to implement some sort of algorithm to solve it. So yeah, if you're here for the logic, that's coming up next. So instead of printing this, we'll return board of colours, and that's it. So thanks for watching, and I will see you on the next one.